Oh, that's a big pointer, man. Jesus Christ.
Yeah, I'm sorry.
I've never seen like a mouse hand that big. It's like one of those big football hands.
Okay, testing 1, 2, 3. Do we have audio? Guys on the chats, let us know.
Yeah, well, live.
Yeah, does everybody hear us?
Yeah.
Wait
The
for
YouTube
the lag.
chat people, anybody on YouTube?
It comes out good.
Does it?
Yeah.
Yep, it sounds good.
Great, great. All right, let's get started for day 4 of the OpenSIPS Summit 2020 Distributed. So we're more than halfway through at this point, and I don't know about the rest of you guys, but it feels like my brain's going to explode. We've had so much good content, but let me tell you, at the beginning, I had planned a lot of kind of transitions and was going to show some movies, things like this, thinking that there wasn't going to be much discussion between the presentations. But guess what? You guys haven't let me any time to do this, which is amazing. I'm so impressed by all the questions and the interactivity with the community and everybody that's been a part of this summit. You've made it amazing so far. Keep up the amazing work. So today, we're going to have 3 more presentations. We're going to be hearing from Shlomi Gutman from Voicenter and Vlad Paiu from the OpenSIPS Project. They're going to be talking about JWT Authentication in UC today. They'll be our kickoff. We also have the most famous Italian, I'm sorry, Lorenzo, but Giovanni is going to be giving us some great information about OpenSIPS and the FreeSWITCH integration.
Yeah.
And then at the end, our esteemed colleague from Greece, Vasilios, is going to be talking to us about multi-cloud journey with the OpenSIPS 3.x. So let's get started. Vlad, Shlomi, you guys are here?
Yep.
Well,
One second. Sorry, guys, to interrupt.
I am so sorry. Hold on a second. I know what you're going to say.
Yeah.
I really apologize for forgetting. So the word on the street is, and the grapevines are chiming, that there's some huge demand for the OpenSIPS training that was going to be next week. And what we've done is on the Summit channel, we've posted a poll. If you're interested still, we're willing to open it up. If we can get enough people, we'll start with we'll add another training day and add all the people that weren't able to get into the first training, second training. So the poll's up there already. We have 5 respondents saying that they think it's a great idea. It's just going to take a few more of you guys to let us know. If that's something you want, we're willing to do it. Talk about real-time communication, huh?
Tuesday class, it's full, and anyhow, we have more people than I originally planned. So to try to, make everybody happy, we said, okay, let's run a second class on Wednesdays on the next day. So if you are interested in taking that class, just let us know. We want to see exactly, okay, if it will be a go or a no-go.
Again, you can find that poll in the Slack Summit channel.
Yep. Thank you, Alex.
Sorry, I forgot.
No worries. But
it's just, again, my brain's about to explode with all this amazing information. So one more thing I just did want to mention. At the end of today, we will have yet another raffle. And part of those prizes are going to be one of these amazing OpenSIPS Summit 2020 t-shirts. I know everybody's jealous. I know you want one. There's a limited supply. And guess what? You only can win it if you're sitting inside the Slack Summit raffle channel. If Live AI 4.7, we kind of jumped, we did a little bit more work, we'll explain that during the raffle again, is in full operation and picking mode, we're going to have a couple of winners. That's going to be one of the prizes, and the other prize is going to be a 1-hour session with the folks over at QXIP. So we've already given one of those away. We're giving the second one away. And this is one-on-one time with all of those guys that are bringing amazing projects like the Homer Project to us. You'll get to sit down, share ideas, and it's going to be just you guys. Really personal, really intimate. So without much further ado, let's get this day rolling. Day 4 of the OpenSIPS Summit starts with Vlad Paiu and Shlomi Gutman.
Yay!
Yeah.
Yeah, so this is going to be a joint presentation. Both me and Shlomi will be doing the talk. So feel free to introduce yourself, Shlomi.
Yeah, I'm Shlomi. I'm in the community and the nodes for around. I'm one of the owner and the CTO of Voicenter. Voicenter is a cloud VoIP provider, one of the first contact cloud VoIP provider. We are around 130 employees located all around between Israel, Ukraine, and our joint venture with Alex over Houston. So it's a great time here and a great place to say again thank you for you guys for the OpenSIPS project and giving us this wonderful technology to play around.
Yeah, I can see you love OpenSIPS. So I'm Vlad Paiu. I'm an OpenSIPS developer, and I don't know, maybe some of you know me. I've been coding, building, integrating OpenSIPS platforms for more than 10 years now. It's been a fun ride. Hope it continues. So let's see what you are going to go through today. We're going to first talk about what the issues are with the current, let's say, regular digest authentication and what are the current limitations. We're going to go a little bit through what's JWT and how we can authenticate using that, and how we can use the dedicated module for it, the Auth JWT module. And then Shlomi will take you through some actual use cases with some other projects and some authentication providers. So let's get to it. Let's see what's the problem with digest authentication. Well, first of all, as the name says, it's just regular authentication. It's not giving us any support for authorization, which of course there are options out there, AAA options, diameter, radius, whatever, but digest is just authentication, and sometimes it kind of sucks. By default, it's using MD5, which I guess all of us know it's not secure for quite some time now. I know there are RFCs and initiatives to migrate it to SHA 256, but it's not yet there. Another thing that's really bad is that there's no safe way for third-party integration. I guess we've all had times when you try to integrate the OpenSIPS subscriber table responsible for digest authentication with other, let's say, tables, whether it's asterisk or FreeSWITCH tables. It's always it's another way, so it's really bad. There's no standard for it. And the last point, I guess, is the most important thing which brought us to the JWT type of authentication is that there's no ability for single sign-on. And this gets really obvious when you go into a WebRTC type of environment where you have, let's say, a client logging into your web platform with his web credentials, and then when that client tries to use the SIP part, the WebRTC part of your platform, you will have to give him some other credentials and then try to make some sort of connection between those. And you end up doing a double authentication, and it's ugly, and it's definitely not the way to go forward. So let's see what is this JWT. It's short for JSON Web Tokens, and it's an RFC specified in RFC 7519. It's essentially a short method of representing claims securely between two parties. And essentially, it's joining of three base64 encoded strings. One is the header. The header contains some metadata about the type of the token. I have, let's say, decoded JWT over here. And this is the header. It just says that the type is JWT and that the signing of it is done with SHA 256. So we'll get a little bit back to the signature. So
And the second part of the token is the actual payload, which essentially is a JSON containing a set of claims that are verifiable by the receiver of the JWT. So again, the claims are represented in a regular JSON format. Over here we have subscriber ID 123456789, the name Dr. Evil, and you can essentially have anything you can dream of over here. And the last part, at the end, is the signature. It's used to validate the token and ensure that it's trustworthy and nobody has changed the payload or the header of it. Because how the signature is built, it's basically a hash over the base 64 of the header and the payload. So while anybody receiving a JWT token can read it and see what's the header and the payload, only if you know the secret over here, you can verify that the token is authentic and that nobody has changed it from since it was issued till it reached you. So essentially, this is the mechanism that we are going to use for authenticating it. And unfortunately, there's no there's no RFC standard for this. It's currently draft and unfortunately not updated for more than 1 year. But what the draft says about how the protocol should work is that the client, let's say, authenticates on your web platform, and after with his web credentials, and then he gets a token from the service, from your service, this access token over here, and then it uses that token for all authentication purposes within the SIP platform. And what the, let's say, the draft specifies is this new bearer type of authorization. For old MD5 type authorization, it was digest, and now we have bearer. And afterwards, it's the after bearer comes the JWT actual access token that the client received. And then it's up to the registrar to take that JWT token and validate it and make sure everything is okay. If all is good, give the user access to the SIP part of the platform. And the module that the registrar is in OpenSIPS is using for doing this is, of course, Auth JWT. Here we have just a short trace done over secure WebSockets of user agent registering with JWT. We see here the authorization header, bearer, and then a token. So let's talk a little bit about the JWT module. First of all, thanks a lot to Shlomi and Alex. They've been the main sponsors of this module, and they've helped a lot in testing it and troubleshooting and making it actually work. So the module is DB driven, and the main information is stored in two tables. One is JWT profiles, and the other is JWT secrets. This is how the profile table looks like. The main identifier, let's say, in a way equivalent to the subscriber username, is this tag over here that identifies the JWT profile. And then we have as a mandatory field the SIP username, because in the old, let's say, digest authentication method, we had the actual SIP username over there, so we know there was a connection somehow. But in the JWT authentication, the token is all that we have. So essentially, we need a way to enforce a token holder to only use a specific SIP username in our platform. So this is how the SIP username token comes in handy. And afterwards, similar to how you could, I mean, the OpenSIPS script writer could make the subscriber table more verbose by adding various columns that you can use in your script. The OAuth JWT module has the same mechanism of specifying extra columns that can be loaded via the load credential mod parameter over here. So by setting the load credentials parameters, you will have the profile info, this column over here, loaded at script level. And of course, you can have as many such columns as you want. Just separate them by column over here, and you'll get them automatically propagated to the script level upon successful authentication. And the second part is, of course, the JWT Secrets table, because for validating a JWT, we need the secrets to make sure that all is good on the signature part. Let's say between the profiles and the secrets, there is a one-to-many relationship, meaning that one profile can have multiple secrets assigned to it. And they are linked via the tag column over here. This secret column has the actual secret that will be tried to be used when decoding the JWT to make sure it's valid. And we also added an easy way of expiring JWT tokens, since you have two Unix timestamps over here, a start and an end. So the secrets are, when they're tried to decode the tokens, they're also verified that they're not expired. So let's say the main function that is exposed by this auth JWT module is the JWT authorize one. It essentially takes three parameters. The first one is an input parameter, and the other two are output ones. The first parameter is the actual token that you want to check if it's valid. And when you call it, what OpenSIPS will do is it will just look inside the token and try to validate it. And what I mean by this is, let's go a little bit back. If we go back to the profiles, we see our tag was in this example space monkey. And over here, in an actual example of the JWT, we see that our space monkey tag identifier is specified in the ISS claim of the payload. So we need to inform the auth JWT module that our tags are located in the ISS claim from the JWT. And this is what this mod param over here does. And now that the module knows where to get the tags, it's just a matter of a little bit of scripting. So we check, we should check if the authorization header is a bearer one, so we don't, by mistake, try to authenticate digest requests via this. We extract the token, and we call the authorize function. So then OpenSIPS will just go to the database, load all the secrets associated with Space Monkey in this case, and try one by one all the secrets associated with it. And obviously, in case there's a secret that can be used to successfully validate the JWT, it means that the token was valid and that we can trust that this authentication in our platform. And the other two parameters are, let's say, used for output. The second one is the decoded token, because sometimes it is useful to also, let's say, inspect the token at the OpenSIPS level. I'll talk a little bit about that later. And we also have the SIP username, which we can use to verify if the let's say the user agent is sending us a proper SIP username associated with that tag. And obviously, they're not sent as parameters, but we also get those extra columns that we specified as load credentials further up. So we also have those automatically loaded. So that's in short how the actual authorization works. And what's nice about it, remember in the beginning we said that digest authentication is just a means for authentication. Well, for JWT, it's a little bit different since it can also be a very handy means of authorization. Like in this example over here in the payload, I have PSTN dial set to true. And since we have validated the token, it means that the server is the one that actually sent us this token. And so we can essentially trust whatever is in the payload. So we can trust that this user that we've just authenticated via JWT can dial to PSTN in this case. So it allows us an easy way to enable, disable various features within the platform on the spot without having to do any, let's say, provisioning changes. So that's about it, what I wanted to talk on the actual OpenSIPS part, and Shlomi will walk you through some use cases and more integrations further on. I guess we'll take questions at the end, probably.
Yeah. Now? Oh. So generally, like the mask in the COVID mask, it's important to use it in the right way. So also the way of using the JWT is can be done in multiple ways. Can you see my screen, right?
No, we don't see your screen.
Oops. Share. Second. Yeah. You see my screen now? Can you see my screen? Yeah. Good.
Yeah.
So I will try to talk a little bit about the different type of implementation and the different usage that we are finding to the JWT authentication. I must say it's like opening a new level of integration and communication between the world of SIP and other worlds as of web and integrations and cloud provider. And I will try to do through some of those different implementations and later also show like a small demo that we build how to use it.
Shlomi, sorry to interrupt you. Just you're breaking up a little bit and quite scratchy.
I think it might be the microphone. I mean, I don't think it's an internet issue.
I'll get in my headphones.
Yeah.
Maybe connect with a cable, or if you're using Wi-Fi, maybe that's the problem.
No, it sounds like some issue. Probably it's using the built-in microphone from the laptop, which in 99.99% of the cases they do suck. You see, that's why it's all the time. It's good to have a lovely brother.
Exactly.
A loving brother. Sorry.
I don't understand your use of "lovely" in that phrase.
No, it was actually
No
like
loving,
loving.
no loving.
Sorry.
And now can you hear me a little bit better?
No.
A little bit better, yeah.
Yeah. Better. All right.
Lights went out, I think. It's getting dark in here.
It's better now, or
No, I think it's the same.
it's the same?
Sounds like packet loss, really, because it's kind of
Vlad, you want to take it from here? I will try to connect from a different one in a few minutes.
Vlad?
We actually have some questions on the channel, so maybe if
yeah, sure. Let's take some questions.
Can you hear me better? Am I sounding good?
So there are questions from Brett Nemirov. First question was, is this mechanism standard enough to see in the wild yet? So basically, I guess
Yeah, it's standard enough in the sense that Shlomi took care to leave breadcrumbs all around, so there is support in the JSIP library for this. But obviously it's not that standard. I think that Janus also has some support for this, but since it's not an RFC, it's not yet fully supported all around. But PJSIP and Janus's starters is good enough, let's say.
Okay, that's some good answer. There are some more. Let's see. He also, Brett asks about revocation expiration process. If you have any more details of how it works, I suppose.
So on the OpenSIPS side, the only, let's say, expiration type is the one done via those two, let's say, columns of start timestamp and end timestamp. So that's how you can, let's say, make the columns, the secrets expire. But obviously you can also, let's say, revocate them from the web server level simply by switching. I mean, having the token generator switch the keys with which they're signing the JWTs, and that's in that way all the secrets that OpenSIPS knows become invalid.
Can you hear me now better?
Yep.
Yeah, good, good. So I will share my screen. So you with me? Can you hear me now?
Yep.
Yeah, all right. Sorry for the delay. So generally, we will talk about the different way of using JWT, how we implement it, and what are the different kind of applications that we have been able to generate by doing this integration. I must say it's really like a very open-minded thing because it's giving us the ability to do a lot of integration that are not basic SIP integration. So this is something that really help us doing a lot of other applications. All right, so the first basic integrations in an application where we are using the JWT is when we want to put our phone inside of a third party like a CRM or ERP, or even like doing like a click to call button for the customer in a customer care portal, or any other kind of way of authenticating the SIP level based on other authentication. For a basic implementation that we are doing now is also putting inside of a lean phone, inside of our mobile application. When you are logged into your mobile, you already generate this JWT, and then you have a SIP registration that also going with some of those push information and other stuff. And of course, we have some clients using it as online games integrations to embed the video sound conferencing inside of the game. Another way in places where we are finding it very important to use it is where we have a huge amounts of potential users that might register to the system, and we cannot get all of those millions of records, or we might not even know all of them. It might be customers that join in our conferencing system, and it's the first time that are doing any interaction with our system. And then we are having the ability to do a secure registration with them based on their registration to a third party like Google or Outlook, Microsoft, or anything like that. And of course, about customers that have a very short period of time and we don't want to even register them, but we do want to authenticate them. So this is another way that we are using it. And Another important thing, as Vlad was saying, by getting another level of authorization and not only authentication, we can limit a lot of the permissions and manage which kind of activity we want to give this registration to do. So if we have like in call center, we are using this to see who can eavesdrop, whisper, who can connect to other agent calls, and who is like a simple employee that is not allowed into eavesdrop the CEO or something like that. So all of that information can be set inside of the JWT that doing the authentication, and we don't need to have any third party integration to know if this call could be made or if this activity could be go in or not. Of course, as Vlad was saying, PSTN limitation, international calls limitation, also IP-based restriction to have like some kind of list of subnets that allowed to connect to this IP and other places you are with this token, and with other IPs you are not being able to do anything like that. Conferencing room restriction, as I was mentioning before, making sure that each one can connect only to his conference and allow to see if he's allowed to share his screen or not sharing his screen and other stuff. Of course, we cannot talk about JWT without generally speaking about SSO. Single sign-on, I like to call it triple SO. It's like a SIP single sign-on, the ability to get connected without any username and password, just by the ability to integrate to a third party that already you're being authenticated in front of him. It's saving a lot of headache on the IT department and the user that need to remember all of the different passwords. And of course, it's limiting the expose to client passwords or third party that should not be seen those information. So this is another great thing. There was a lot of demand for it in the SIP world, and it's something that our client and especially the IT departments that were of our customers really happy that we have. Another thing, another kind of permission that it's important to talk about is about the ability to set the permission over the third party. So let's say, for example, I'm connecting now to through Google, so I will get the access to this client contact list. So I will be able to do also caller ID to caller name, finding his caller name by the contact of these customers, displaying like in our software the contacts list from your Google account or from Microsoft Active Directory or any others or the exchange contact list of the organization. And another way of getting permission is like by the end of the call, taking the recording of the call. And this is something that like we are passing through to the media gateway, this token, and is being able after the call to store a record of this call over the specific drive or storage or bucket of this client, depends on where he did the login through. Another way that a lot of our customers ask us to do is to get on the end of the call to create an entity to this client that we just talked to, and even give a link to the record and everything over the permission that you already got once the client did the login to the soft phone or any other phone that he is using. So a lot of those third-party integration is being based over OAuth protocol, OAuth mechanism. It's like a mechanism being pretty much industry standard to give a third party the ability to authenticate and use your and like replacing the needs of giving credentials to a third-party application that want to do something in front of a different one. So generally, the flow is between this client that's asking the local application, and then the application is telling the client to go authenticate this in front of this authentication provider, and then the authentication provider usually through a redirect will give the application itself is the token, which with him you will be able to do all of the activity and the authentication and everything. So, for example, for the flow, if we have a joke, it's a great client of us that is coming to us and say, hey, Voicenter, would like to make a call and save it as a record. Then we are telling him, great, let's go to Google and ask for permission for it. And then we are we're asking as Voicenter permission from Google. Hello, Google. I have a user that would like to make a call and save his record on your storage. Can you give me a token for this request? And then Google will give us this token that we will give to the client, and then the client will go to Google and actually get this authentication. And then after that, when the user coming back to us with the approval and the token and everything, we can see that the call is really the token is really the token that he gave us, and then we can make the authenticate is to make the call. Like we will check by the public keys of the certification of Google to see if this token is okay. And when the client will send the register with this token, we will give him 200 super okay. And after the call will be ended, we will be also being able to ask Google to store this recording with this token. So this was a quick brief over authentication flow, and so we will talk about how do we make this SIPK recipe. What is the secret ingredients and how does it's working? And I was trying to make a very simple low-word application that doing all of the great stuff that we discussed about moving the authentication between Google and the user. So what is the recipe? What are the different things we need to put in there? So we need one HTML page to be the phone. We need one login form. We need different three very simple JavaScript functions. I know most of you are not web developers, but I will try to give it in a very, very clear way of like one function getting the configuration, one function doing the register, and one function doing the call. And we need to have some kind of a web server backend without login mechanism. Each one might use his own backend technology. I was trying to give like a very, very simple example of how to do it with Node.js, but for sure it can be done with dozens of other programming languages. Each one will prefer his own language and his own libraries that implemented it. Most of the time you are not implementing all of the logic by yourself, but using some of those already been libraries that implemented to your the OAuth mechanism based on the language you are writing in. And another thing we will need to have is to make to register as a auth in front of one of the auth provider. We will need to have an application. And we will need to store some signature in front of the database to make sure that we can verify the Google JWT by their public signature. So let's go over the different ingredients. So this is a very, very complex login form. I don't think you need to know HTML to understand that there is one button in here that's going in to connect to Google URL. And then we have the phone. It's a very, very fancy phone. I did a lot of designing on it. You can see there is a button register and a call button. And we are actually including the JS SIP libraries, which already been implemented with the JWT authentication and the authentication header in their implementation over the code. So what we do is give a basic token parameter. So let's look how does it look from the INBC. Again, as I was saying, we are using JS SIP. You can see that first we are doing getting the configuration. And when we are hitting the register, actually is getting the config from this function. And inside this token, we pretty much, the only thing that fancy over here is that we are taking from the URL, from the search bar, we are taking the token parameter. So we are taking the token from the get parameter inside of the token and parsing it inside of the authentication JWT parameters that the configuration of the JS SIP is having. And after we are getting the configuration, initiating our great new soft phone based on JS SIP, we are just letting him know to start. And when we're doing the start, is actually sending the register request that we could see it actually later in the example. After that, we'll be able to do a call button. Generally, nothing fancy about the call function. It's all what he's doing is taking this UA object that we just declared over here on the register and telling him call, and he will call to this URI. Of course, you can control if you want to send the media SDP audio or also video over the SDP. And another thing that it's a little tricky in here, you need to tell him, like when the call is being connection and when you starting get the stream, to make sure that you are passing this stream into your authentication, into some audio elements that will play. And actually, I don't know why. It could be thinner. You can see over here, you have after it, we are doing play to the audio, and then we will be able to hear the actually sound. The last part that it's not trivial, it's doing some kind of a backend. Again, I'm using Node.js with the Fastify library, which give us a very light, nice scale web browser, web server. And generally, you can see that most of the logic is being in here. Beside like loading the grant module, which is a library who manage the OWT integration for us, beside loading it with this config file that we will go over it in a second, we are not doing too much besides saying over here, if we have a session with a grant with already the grant response that we got, then we need to go into the to the phone HTML and put over the URL the token. Otherwise, go into the login page. So beside that, we can see that how we going to Google to register as a client ID. So you actually need to go to Google Console for developers, and over there, over the credentials, adding a new web login to a web. Few important things about this page. First of all, we are getting the client ID and the client secret for this integration, and we will actually will use it later on inside of the configuration. And we need to make over here the list of the URL that are going to be provided, that are giving us that they will be able to access to this integration. And we have a list of the callback, what are the URL that are being able to get the information back from Google when we are redirecting the client after the authentication. And the config.js, as you see, the only thing that we need to tell pretty much about the Google information. By the way, the grant library is having a few dozen, even I want to say almost 100 different authentication provider that you can use. So each one can implement his own provider, and each provider get some different credentials that you usually will need to set up once you are registering in front of this suit provider, like we are seeing over here in front of Google. Another thing that we will do is pretty much over the scope, we will declare which kind of authentication we want to get from Google. And by this authentication, we are giving the client is giving us permission to do different activity inside of his account. So basically, it's OpenID and email giving you the basic credentials. I'm also like to ask like for the user aliases, if you have a different aliases. And of course, if you want to do like get rid over his contact or any other permission, you can go over Google documentation. There is like hundreds of different scope that you can see over there. Another thing that you are actually getting over here when you are downloading the JSON, you are getting this URL of Google for who give you the different certificate. And those are actually the certificate which are set up inside of the secrets for the JWT authentication, so we can authenticate without going back to Google as the RFC suggests to us, but we can do a shortcut and already authenticate those tokens just by those secrets. So that's generally the basic way of how to do it. Again, we will need to make a folder with all of those 5 files. Start a new NPM project, installing those basic NPM libraries that we are using, installing those files, doing the create Google authentication, and import the Google JWT inside of your OpenSIPS JWT secrets. And of course, running it. As we can see, it will give us some kind of a login page that when we will do a submit, it will give us like this Google sign-on page, and then will redirect us into the phone, which we are having the ability to register and make a phone, and we will be able to see like how does the phone is look like. And then it's the register being sent with the authentication barrier and everything. And from OpenSIPS side, we can see it's actually getting the call. And over here, we are doing like a basic UAC replace from to change actually the email of the user from the what we got inside of the inside of the JWT email parameters of the body. So this is generally, and of course we can see also we are adding inside of the header the OAuth username and your email that you authenticate with. So that was a quick overview of how making your own JWT implementation. I guess this is time for questions.
Okay, sounds Shlomi. Yeah, I think we have and Vlad too. And by the way, yeah, there are some people who are very interested in doing this type of tests as part of OpenSIPS. So maybe when next time we do it, they will already have some kind of RFC, and we can ask you to help us to test it. Anyway, there is a question from Brent again. It says, what is recommended way to persist the payload metadata throughout the dialog, or is it expected that the payload arrive on every new transaction?
So generally, by the RFC, it's pretty much expecting it only over the register, but different application, you know, it's still like a pretty flexible area. So if you are loading all of the credentials and everything by the registration, so you not must send it on each invite or on each other transaction, but generally, as we implemented it inside of JSIP, it's actually sending it on each transaction, on each request that you are doing, even if it's in a mid-dialog transaction.
I see. Hopefully, it answers the question. Is it going to add a delay? What kind of usual delay you have? Say from Google, what is
so
kind of
again, if we are using the certificate in the way that we implement it inside of the module, so you are putting the public signatures of Google over OpenSIPS, then we are talking about far lower than 1 millisecond, because it's all what he's doing is a very quick OpenSSL decrypt that making sure that this is the real signature. So I want to say lower than 1 millisecond. Vlad, you have a better guess?
Oh, okay, so it basically is not calling external external services during transaction. Okay.
By the way, I have a big, I didn't like that the RFC by default say that, all right, when the SIP registration getting now go to a third party to do a HTTP request. I think it's like not understanding the way that real-time communication and a telco and a VoIP and a telco operation working, which are very mission critical, and we could not allow ourselves to have more delays or more point of failure. And I think the right way of doing it is actually making sure you have the public keys of those who signed in those JWT. And it's definitely a good practice to use private and public signatures. For sure, Google will not give you their private signatures. You could be very rich if you have them.
I see. Does those certificate expire, so you have to update them periodically? What is
so actually, as I was showing earlier, there is a web service that you are going into it, and you are just getting the certificates. So you can do some kind of a backend process that maintain that get the update signatures and update them to the DB. I don't know, like from the last few weeks that I'm playing with it, I didn't saw Google change once their certificate, but yeah, it's probably a good practice to have some kind of a backend process that once a day or once every few hours asking from Google to see if they got crazy and change one of their certificates or something.
I checked the certificate and they expire this month, so probably I guess it's a monthly renewal or something.
Oh yeah, okay, monthly renewal. Then it basically probably needs some automatic mechanism.
Yeah. It's like...
I have a question, guys.
Yeah. course.
Regarding the security, there is no refresh token. So how do you deal with that internally? If the user changes the password, if you understand what I'm saying.
Yeah. So again, anyway, the refresh token is an important implementation that probably should come from the client side anyway. And when you are doing like the registration, actually, I was showing over here like that you are setting up. When you are setting up your, no, you don't see it in here, it's cutting off, but when you are declaring over Google, you can say how many hours you want it to be alive, and you have the ability to like refresh the token from the client side. So for sure, let's say the refresh interval of the token from Google must be lower than the registration timeout of the SIP. But anyway, like we are doing today, probably registration, most of the people around 1 minute and to 10 minutes. And so, yeah, once in a while, client side is supposed to go to Google and do a refresh over his JWT with the refresh token that he's getting once he's logging in. Of course, this HTML demo doesn't really have that. But
you can, by the way, you can enforce a reinvite from OpenSIPS, and then you can force the re-registration.
Yeah. But anyway, like you must get in front of Google to refresh your JWT. Like one of the things that you have inside of Google JWT is the expiration, and it will be lower than the total expiration of the permission. So you probably get in like half an hour or an hour, and then you will need to refresh it by the time that is updated.
One more question maybe regarding to this also. How you can force a user logout? Because even if you delete the JWT token from the browser side, if it's not expired, it's valid. How can you deal, or have you faced situations like this?
Generally, like again, the idea is that until like the user is log out, but I guess again, like if you will log out, then you will not be able to refresh your token. So the default expiration will be by the JWT expiration. So even if you left it behind, I would say it's not a smart thing to put the JWT token as I did inside of the get, like near, because then the browser will put it in your history, and it is something that you shouldn't save nowhere public, you know. And if you are getting out from the browser, it should already delete it. So.
Okay.
There is Google like giving you the ability to revoke a permission that you already gave to an application, but again, it's probably just make sure that you are deleting the token from the place where you are using it, and then you are not using it anymore. Like.
But if you want to disable a customer for a reason, or disable a service for a customer, it's not possible until
then again, you need to make sure that the server know about this customer that you are not using it. For example, like make sure you are changing his profile, his SIP user, or change his profile over the JWT profile tables. So you have a bunch of abilities of doing it. This is more of like example of a short POC. Of course, there is a lot of mechanism you should add over it when implementing it over production.
Okay, thank you. Nice presentation.
Thank you. Sorry for the bandwidth problems.
That's okay. We still have another question out here. Does OpenSIPS inherently support revocation?
Again, with OpenSIPS can.
Does OpenSIPS inherently support revocation?
Again, it's something you will need to do from the client side. So if you are need to recreate a JWT, you will do it from the client, and then OpenSIPS will be able to authenticate it. OpenSIPS will reject all JWT if it will be expired, but the ability of regenerating it need to be probably done from the client side. You can do it also from server side, but it doesn't make any sense for you to do communication of behalf of the customer to Google. You will probably, it's not so secure for the clients to send this refresh token anyway to OpenSIPS. So I don't think it's like the best way of doing it, but it's something that should come from the client side probably.
And then, do you have any recommended expiration time for the tokens?
Again, it's very depends over the use cases. Like as for, to give example for the last question, if it's something that you will want, if someone not being able to regenerate a new one to log him out, it depends of the use case, but I would say no more than the maximum length of a call, that is around 2 hours in our industrial, like 2-3 hours. So I wouldn't put it much more than that.
I think it's best practice for JWT to be in minutes, not in hours, for the reasons we spoke before.
Exactly. Yeah. No. That's what I'm saying. Like we have like integrations where we need to do stuff in the end of the calls and stuff like that, and then we will say, all right, that will be the expiration. So we will know that always when we are starting the call, by the end of the call, it still will be valid. But
yes.
if you don't need to use on the end of the call this token, so yeah, just make sure it will be very short and make sure the client is refreshing it once in a while.
It also probably means that for this to work properly, your server time should be synchronized pretty well, right?
Yeah,
so
yeah.
If you're off by, I don't know.
Yeah, don't forget the basics.
yeah. It's for sure. Anyway, it shouldn't be like seconds. I think, again, everything between minutes to 1 or 2 hours is reasonable. Anything else is already will give us some application problems or will be not secure enough.
Yeah, okay.
I don't know if you guys have noticed this, but the brothers have switched. Shlomi is now Nitzan, and Nitzan is now Shlomi.
Nitzan become beautiful.
They're interchangeable.
Do they do that often?
It's a redundancy thing.
They are in replicated mode.
Yeah. Never done with girls.
Nitzan, you forgot to unmute your mic. Yeah.
Yeah. I was just saying, I feel like this would happen with it, and he was be talking, and
hey, Giovanni, do you want to start your presentation?
Yeah.
Okay, ladies and gentlemen, that'll be the end of our JWT presentation. Let's give these guys a round of applause. That was awesome. That's some really new, cool, like authentication stuff.
Very helpful.
So our next presenter, the creator and founder of the B2B, the back-to-back, I'm hoping that by the end of this presentation,
I know what you're going to
one.
You're going to ask him to do the back-to-back dance, aren't you?
I'm hoping. That's it. I'm just letting him know that there are people out there that want to see this.
Great idea. Come join us. Come. He's our hero. Yay!
So without any further ado, ladies and gentlemen, Giovanni.
So let's start with one caveat that in the last 2 or 3 days, my PC is kind of unstable.
Hey, Giovanni, a little bit, sorry to interrupt you. Maybe turn the voice level of your mic a little bit down. There is a lot of
One,
oh,
two,
it's
three.
better.
1, 2, 3.
Worse,
That's better.
No, it's worse actually. Like maybe volume a little bit.
Okay. 1, 2, 3.
But you'll have probably speak. You'll have probably speak a little bit louder. But
okay, I will try to speak louder, and I don't know how long it will bring my voice up to until the end of presentation. But first thing first, maybe my computer will freeze, and then please bear with me, and I will reboot the computer, and I will be back. And second, is the presentation, is the slide, you can see it? Hello?
Yes.
good and clear.
Yes,
okay.
we can.
Okay, perfect. And so this presentation will be about how to scale services, specifically voice over IP, both the classic one and WebRTC, and particularly using FreeSWITCH and OpenSIPS as building blocks. And so probably there will be many known things for all bands in FreeSWITCH and in OpenSIPS, but I hope to do some cross-pollinating between the two communities. And without any more waiting, let's go to the slides. So I'm Giovanni Maruzzelli. I'm a consultant. It's a very long time that I'm in this industry. I wrote some book and done some speech. What is to be done when you build a VoIP service, a SIP service for a customer, and particularly for an ITSP or for a carrier, or something like PBX in the cloud, or services for residential or small, medium enterprises. You have many building blocks that you must combine in the best possible ways and to deliver something that is reliable and that makes sense from a management point of view, because apart from day one, you then have some years and years of operations, and so it must be operable. So you have security, high availability, and then you must deal with registrations. So you take count and you keep where each phone is and how to reach to that phone. Then you manage presence, BLF, NWI, and those are all the lights, the little LED that are on the business phones that tell you when someone else is on a call, so you can forward him another call or is busy. And or if you have some message waiting for you in your voicemail, then you will have the blinking light that tells you, please push the button and listen to your voicemail. And Then you have calls that are internal to your customer network, so extension to extension, let's call it. Or you have calls that from the external world, from PSTN or some other gateway, want to reach your customer or vice versa. Then you have all the particular services that are like IVR, automated attendant, conferences, queues, automatic call distribution, transfer, all these special cases. And then you need to deal with NAT, network address translation, that is almost for sure the front end of your customer. So you can't reach him directly. You must pass through its own little router that often is not very reliable. So let's approach one by one all these parts, and let's see how we can solve each part using FreeSWITCH and OpenSIPS. Security. There is this buzzword, SBC, Session Border Controller, that more or less is devoid of any meaning, because in the industry, this kind of acronym is used to denotate totally different things. So we will try not to use this SBC word, but let's talk in terms of what is our front end or single point of contact with the internet. And we will see that in our architecture, we tend to use one only point of contact with the internet, so one only public address, and all the rest is behind in a private network that is not reachable from the public internet. That means, in a way, very easier to secure than having multiple point of contact with the internet and multiple machine, multiple systems with different architecture, etc. And obviously, you will need to use a specific feature of your operating system that will probably be FreeBSD or Linux, and so you will use its internal firewall that can be PFSec, IP table, or whatever, and then you use on OpenSIPS the modules that give you a first line of defense in terms of denial of service, in terms of checking if there is nothing particularly strange. You can also filter for user agent, so you can filter out vicious, people clear, etc. All the easy spottable probes that comes from the internet. And this is, let's say, the first line of defense of you. And then you have the high availability. You want to have your service that's reliable, that can survive the crash of the machines, and that automatically make good from any damage that can happen. So first things first, double your OpenSIPS. That's your point of contact with the internet, and the RTP proxy, that can be RTP proxy proper or RTP engine or media engine, etc. And so double or multiply those machines so they can survive a crash. And in the easiest way and the simplest way, you will have two such machines that are in active passive, and you will just move the virtual IP address from one to the other with keep alive. That's a daemon that do VRRP to moving the IP addresses, and you will use it, this keep alive with some functional testing, so you can be sure not only that the machine is up, because many times the machine is up, but the SIP calls do not terminate, and so you must check in collaboration with Keep Alive. You can use a test program that will communicate with Keep Alive about the health of the platform. So if the calls are not terminated or other tests are not successful, you will change the status and you will fail, and Keep Alive will move the external IP address, the virtual IP address, to the same machine, and the service will continue seamlessly. While let's see, this is the picture that I often use for my presentation, is 10 miles in the sky view of the old platform. You have on the far left, you have this yellow rectangle. That's your gateways to the PSTN and to other carriers. Is from where your DID's calls comes into your platform, and is where you send the calls to the external world. So to carriers, to mobile operator, etc. Then a little bit up, you have all the phones that are in the customer premises. So they are both desk phones, or they are app on mobile, or they are WebRTC on the browser. And both the ITSP and the customer phones will connect to our single point of contact with the internet. That's our two machines in active passive that do SIP proxy and RTP proxy. And then on the we pass in the internal network that is not reachable from the internet, and we have our FreeSWITCH server farm with our Postgres SQL cluster and our cluster FS cluster that give us a redundancy for both storage, persistent, and for file system. First things first, we need to understand what is the correct role for each actor. And we must ask to each one to give his best for what is able to do. And so you will use FreeSWITCH as a media server, as an application server, as a business logic. So it's a platform that gives you a very easy way to program very complex logic using complete languages like Lua for your interaction with databases, with your CRM, with your customers, etc., etc. So very complex and very high-level functions will be taken care by FreeSWITCH as a back-to-back user agent. Back-to-back user agents means that is acting like two phones connected into one. So it will receive a call, it will answer a call, and will originate another call, a new call to the peer, and then it will bridge the two calls, making the media stream, so the voices or the video, go back and forth between the two endpoints that are connected. So you will use FreeSWITCH for all its very advanced capabilities in terms of media and in terms of interaction at high level. OpenSIPS is a proxy, and it's able to do all the heavy lifting that you need into a telco operation, and particularly it shines so much in all the high frequency, high volume transaction per seconds area. And this is where you want to use definitely OpenSIPS because it's so much more efficient for doing hundreds, thousands, or almost millions transactions per second into using the proper hardware. And is order of magnitude more efficient than FreeSWITCH. And that's completely logical because it's a totally different piece of software and with totally different aims. So you don't want to misuse FreeSWITCH, and you don't want to try to coerce too much complex logic programming, and particularly media programming into OpenSIPS. So to each one its own, or from each according to its ability.
Giovanni,
Yeah.
just in respects to this kind of a separation you did over there, over here. So in this slide between what each party is doing. I mean, FreeSWITCH versus OpenSIPS. I will show tomorrow some magic that will definitely move a bit this border between what each can do. So that just a kind of a heads up.
I know very
things
well.
are not anymore so well defined right now.
Exactly. I know very well that, and if you remember when you were introducing this OpenSIPS distributed 2020 edition, I told you, I mean, you are moving, totally moving the border, and I mean, the more and more you will be able to move many functions that up to now were better handled by FreeSWITCH into OpenSIPS, and FreeSWITCH will be more and more particularly on the high media capability thing. But we will see, and I'm so enthusiastic about the new things that you will be presenting. So let's start with registration. Registrations are the most high-level transactions that are running around in telco, particularly if you want to be very reliable. I often use 120 seconds for registration. That's because I don't want to leave too much gaps into knowing exactly where all my customer phones are. And this is when you reach some real numbers, this is a totally impractical frequency to manage to FreeSWITCH, because as many other kind of transactions is just too much. And so you definitely want to manage this via OpenSIPS. But how you can do this? You can do this with a specific module that's called mid-register. This mid-register, what he do? It acts like it was the normal register for OpenSIPS. So it do client registration, it do end use endpoints registrations in OpenSIPS. But it has a function on top of it, and this you can tell mid-register that each, let's say, 1 hour, it will send the registration to FreeSWITCH. So in this way, it acts as a demultiplier. And so it will receive a registration each 2 minutes from endpoints, but it will send only 1 each hour to the FreeSWITCH. And when you have all the FreeSWITCH farm on the back, and the FreeSWITCH farm and the FreeSWITCH farm has its own internal backend on database. So OpenSIPS will send a registration to one random FreeSWITCH part of the farm, and they will all share this registration immediately because it's in the database. One important tip to remember is that it will be very valuable, very handy to you to have a script to reload from the mid-register to the FreeSWITCHes all the registrations, particularly if you purge, if you clean the registration database of FreeSWITCHes, you want a mean to repopulate it at your will and not waiting maybe 1 hour for the next for next time OpenSIPS will send the registration. Then another very heavy area is presence and DLF. So all the things that are generated as a statuses when there are calls going on certain phones. And for example, in office is very often you have all the blinking lights that tell you all your colleagues if they are in a call or not, if they are busy or they are free to accept a new call. And this compounds. So if you are 20 people in an office and each one people monitor the call status of all the others, you can understand how many of this monitoring is going on. And for each blinking light status is a message or more than a message, and all the transactions that goes around, and you definitely want to have this managed by OpenSIPS, because it's heavy lifting. And you can use FreeSWITCH for all the things that are ready-made for you in a smart way that are already integrated, for example, into FreeSWITCH itself or into Fusion PBX or other platforms. For example, using some light Lua scripts for sending a message waiting indicator, MWAI, that tells you you have some voicemail waiting for you. And one tip here is you can reach the OpenSIPS generated notify in case of presence and DLF using the local route, and there you can manage to massage, alter, edit the content, expedif, or the content of the notify, so you can make it compatible and with a specific kind of phones. This again to refresh our view of the platform. And so let's see the calls. We have two different parts in the call management. One part is about the signaling, so the specific SIP part that denotates who is calling who in text. And another part is the media, so the SDP that contains the in text where to send the audio and or the video, and where you get the video or audio from. And the problem is that in the totally different way than HTTP, than the web, in SIP, in real-time communication, you have those two series of addresses, so the signaling and the media addresses, that must be related and managed, but that normally are not managed automatically but by the network, because they are written as text into the messages. So we must alterate those messages and manually change those addresses into text messages. So we must parse the text messages and alterate those addresses. And we will see that is kind of complex because you have a flow into the message and a flow into the reply. And each one must be managed. So in FreeSWITCH, you have the concept of profiles. SIP profiles in FreeSWITCH are a couple composed by internet address, IP address, and port. So you can have many such profiles. Normally are on the same address, but different ports. And you give these profiles different properties. And normally, by convention, there are two profiles. One is called internal, and one is called public. The internal profile is the one that got a default dial plan. This is also named by convention, and is where you connect the internal phones, and is a trusted environment where you can accept the calls, send the calls, use PSTN gateways, etc. This is, let's say, your local area network where you connect your phones. This is FreeSWITCH. Huh? And then there is another profile that is called public that we will see that is not trusted environment, is the one that connect with the provider or the DID provider or the ITSP, and so through the internet, and that profile will not have the possibilities to do dangerous things like using for pay gateways, using services, etc. It's an untrusted environment where that you use just to receive calls or to send calls to your ITSP. So those two main difference profiles, I repeat, one is used to manage the internal PBX services, and the other one is used to manage the connection between the PBX and the external world. This is from the start of FreeSWITCH as a complete PBX environment that will connect directly to the internet. We use FreeSWITCH as a tool set for our complex and scalable architecture, so FreeSWITCH will never connect directly to the internet, but we will have usage for those two profiles the same. So in our platform, phones only register and deal with OpenSIPS. And OpenSIPS is the only point of connection with the internet, is the only things that is connected to the external world. And phones will never send signaling or media to FreeSWITCHs. FreeSWITCHs are actually not even reachable from the public internet. All is passing through OpenSIPS and our RTP proxy that will route the media, etc. FreeSWITCH knows that the phones are registered to OpenSIPS, and will receive and send the calls to OpenSIPS. This because mid-registrar will send to FreeSWITCHes a carefully crafted registration that will make FreeSWITCH to connect to OpenSIPS and not to directly to the phones. So when FreeSWITCH wants to reach a phone, it will pass through OpenSIPS. In this way, FreeSWITCH will treat all that comes from the port 5060 of OpenSIPS, or another port, but a defined port into OpenSIPS, will be treated by FreeSWITCH as its own internal traffic. So it will use, if the call comes from that IP address in that port, OpenSIPS, it will use the internal profile, FreeSWITCH profile, and that has the dial plan that give all the PBX services. Important, don't use port 5060 as your public internet OpenSIPS port. Use another random port, I mean, whichever you choose, for example, 5070, and you will save the burden of being continuously probed by the internet wannabe pirate. And this is not a problem because you will keep them off, but it just, I mean, they will pollute your logs and why to accumulate the records of their probes. So we have our flow that comes from the phone that is on customer premises behind router, so it's probably NATed. I mean, 100% is NATed, and it will arrive to OpenSIPS. OpenSIPS will send the phone the RTP proxy address into SDP and send to FreeSWITCH the RTP proxy internal address to FreeSWITCH. So at the end, you will have RTP that will flow from the phone to RTP proxy to FreeSWITCH and then back. And this in case, for example, the customer is calling an IVR in FreeSWITCH. And so there is no bridged call, but it's one leg call. And when you have an internal call between two extensions of the same customer, you will also have a flow that is very similar. So remote phone will get RTP proxy address to send the media to, and FreeSWITCH will get the internal RTP proxy address to send the media to. Then FreeSWITCH will originate a call and give it its own SDP address, and the call will transit through OpenSIPS and RTP proxy and reach the peer, the phone B. And so all the RTP will flow from phone A to RTP proxy to FreeSWITCH. Then FreeSWITCH will route the SDP, the RTP to the newly originated call to phone B passing through RTP proxy. And when the call is established, you can then do some reinvite, for example, to not having FreeSWITCH in the media path and having the RTP, the media, the audio or the video, going directly through RTP proxy without passing by FreeSWITCH, or directly stay in the LAN between the two endpoints. Experience taught that the best way and the most reliable way is to keep the media flowing through RTP proxy, so it's reliable also if endpoints disconnect or change network or whatever, and keep the signaling passing through FreeSWITCH, so it can intercept all kind of signaling, particularly on hold for generating specific customer music on hold, and other kind of signaling like refer, reinvites, and things like that. Also, when you keep the signaling going through FreeSWITCH, it helps you because then you can generate reinvite when it happens to need audio from FreeSWITCH, not only in case of music on hold, but for example also if there is need to do recording during a call, or when you need to do text-to-speech or automatic speech recognition during a call. Again, our picture. And let's see how it works from external. I see that the time is running short, so I will go very fast. More or less, let's say that with PSTN, it works the same that for internal calls between extensions. The difference is that passing through a specific port, both in OpenSIPS and in FreeSWITCH, it can choose and it will be forced to use a specific SIP profile in FreeSWITCH that is enormously more restrictive and that will correctly distribute the DID to the internal extensions. And obviously, you want to firewall your external port of OpenSIPS, the one that connects to the gateways and the ITSP. And I will go fast in this. Okay, let's jump to the special cases. And normally, all the calls are just dispatched in a from OpenSIPS to one of the FreeSWITCH servers in an algorithmic way that can be random, can be round robin, can be weighted for load or whatever. But there are cases where you don't want your call to just go to one FreeSWITCH by an algorithm. You want a related call, related call from the point of view of FreeSWITCH to stay on the same FreeSWITCH machine, particularly the ones that need to have their audio, their RTP streams mixed into FreeSWITCH. So conference rooms, queue, call centers, and things like that must be on the same physical FreeSWITCH machine, or that machine cannot mix the audio. And there is kind of easy way to conceptualize this, and you identify the to which extension, and an extension can also be an IVR or a service, on a queue or whatever, to which extension the call is going, and you keep track of it. And if there is another call that is or going to or coming from an extension that is the same or related to that extension, send it to the same physical machine. And so let's say you, by default, you use an algorithm to distribute the calls on whatever machine the algorithm deem is the right one. But in case you check in the database and see that one incoming call is related to some calls that is already ongoing, then send it to the same FreeSWITCH machine. Another special treatment that you need to is keeping care of NAT, particularly of keeping a pinhole into your customer router open, so you can send them a call. The things that often happen is that they can call, but they can't receive calls, or that you have some sort of one-only way audio or things like that. Often all these things are made because the router on customer premises is closing ports or closing pinholes. And so what you want to do is keeping that open, sending option messages. This also is exactly what you want to do from OpenSIPS. FreeSWITCH can do that, but you don't want to use it to do this in an industrial grade environment, because it's just too much transaction, and also the mechanism of FreeSWITCH is too much heavy to go to the big numbers on this, and it do each time a check on database, etc. So you want definitely to use this from FreeSWITCH, and you can add to that also as a tip a periodic reinvite, let's say each 1 minute or so, just to be sure, particularly with TCP-based communication, that they have not disconnected, or ports are not closed, or they have not changed the network. And okay, we leave 5 minutes for questions and some trivial tips. And use OpenSIPS to do the trace of SIP messages and send it in using the HAP protocol. And so you will be able to visualize a complete SIP flow from also from TLS and WebRTC, things that you cannot do just intercepting the network flow because it's encrypted. And so you will be able to use both OMER and SNGREP to visualize what you send to them through HAP protocol. and use aliases. Aliases are a feature that is not very known, but you can have aliases both in SNGrep and in Homer. So you will alias all the addresses of your gateway or your proxy or your media servers and give them some names. And so they will be shown into the ladder graphics and the SIP flows, and it will be so much easier to understand the ladder, and you will easily see which one are the phones in the customer premises, which one are the gateways, which one are the proxy or the media servers. And use directory trees. This is particularly important if you use a network storage like NFS or Gluster FS or etc. Because all network storage has a heavy cost in listing directories, particularly if they contain many files. So if you create a directory with, let's say, 10,000 files, that is not so much, that is nothing. If it's on a local directory, because they will be kept into kernel space, into the file system cache. But if you are using some network storage, you will block and stay for 5 minutes just to receive the listing of the directory. So do directory trees. You can organize as you want in a random way or in a logical way. But use directory trees. For example, in this slide is year, months, day, hour for accumulation of related time-related files. Another trivial tip that comes to my mind is when you are looking at the name pane of SNGrep, where there are the list of the calls, if you press capital A, the cursor will go to the last call and will self update, staying always on the last calls. So it's actually keeping you on current without you to press the arrow keys. And
Nice.
there are maybe
These are not trivial tips, by the way. I don't think I knew 2 out of 3. Thank you.
No, thank you to you to be so nice. And but both of these things, for example, particularly SNGrep, has many of those tricks. For example, also when one important things that you want to do is particularly on back-to-back user agents like FreeSWITCH, and this is important also for Homer. When you originate a call, you originate it and add an header, an X header with X call ID that will report the call ID of the call that has originated the new call, the one or more new calls. This will give you the possibility in SNGrep and in Homer to click on the original call and see the complete flow with also the other legs. So you click on the A leg and you will see one ladder with all the B legs that are originated from the A leg. And when you are seeing that, if you press multiple times C to have the ladder made with coloring for call ID, you will have so beautiful and easy understood ladder by the various call ID, and if you use aliases, it will be the best possible.
Just to recap what you said, all we have to do is to include the X call ID header, and both SNCrect and Homer have the necessary code to pick it up, right?
Correct.
Wow. So it's X-call-ID or?
I'm sure it's multiply documented, and it's X.
I'll look it up
X
for you.
dash call ID. I think is X dash call ID.
I got some questions from, or not questions, maybe some comments for you, Giovanni.
If you have just time for, I will just show you because it's nice.
It's X-call-ID.
Yeah.
Or I think there is a shorthand version. Not sure if this is correct. X-CID. Shorter.
That's probable, but I will show you one.
Maybe we should move to the questions.
Okay.
We are a bit late to the time, so.
Okay, just.
And people are of course anxious to get the truth from you.
I'm anxious.
Yeah, see, Maxim is very, very anxious. He wants the truth.
Giovanni, well, we're waiting. Thank you, Bogdan. We're waiting for people maybe to post some questions on the chats. Just a quick observation, or not so much observation, maybe some ideas on what needs to be improved. With all that crazy stuff that you displayed with people sending call to RTP proxy and then to FreeSWITCH and do some processing there and then sending it out. We came to few cases where that did not play very well with the NAT detection. And they basically ended up creating like 2 sessions in RTP proxy, like one in, one out, and then this FreeSWITCH tried to drop out by sending some re-invites. But what happened is basically the proxies keep kind of loop going, so it never really released that. So there's some documentation, maybe, I don't know, or some improvements to be made on that end.
Actually, is one of the most interesting things for me, and there are many moving parts in all this. You have the phones, you have the FreeSWITCH, and you have OpenSIPS and RTP proxy. In FreeSWITCH is, let's say, made, I mean, the spontaneous behavior of FreeSWITCH is to behave as he is alone in the world, and he is directly connected to the internet. So he has no idea of a proxy or not for media, not for signaling. Is an all-in-one package, let's say. And also is an all-in-one package that is a little bit of an hybrid because obviously it must also behave a little bit as a proxy or, for example, as a register or things like that, but is a B2B. So complex things. You have to coerce FreeSWITCH not to do things, not to do its own idea of how to do the reinvite, its own idea on how to do the refer, etc., etc., etc. So it's to tame FreeSWITCH, not to take its own initiatives, its own idea of how to deal with things is an endeavor into itself. And then you want to substitute those things with your things because you want to have music on hold, refer, or things like that. You want to be able to reinvite and move the RTP stream from the tree level between phone and phone, between phone and RTP proxy, or between phone, RTP proxy, and FreeSWITCH. You want to be in control because the platform is yours and you want to decide things. And this is a little bit complex, and it requires you to control strictly FreeSWITCH. For example, it has a lot, really a lot of control on how to move the RTP stream, and how to do that if there is a music on hold, a reinvite, but it's all high level and let's say automated, and are all those things that I mean, for example, into browser that they you begin to write something at if in the browser complete for you and probably is not what you wanna write, or T9 on your cell phone, etc. So you must keep a lot of attention, and it's really is a complex art.
Anyway, thank Giovanni. I think Alex is looking at us very angry. So
I'm looking at the timer, but it's all good. These are great questions. That's why we still have the Summit chat and the YouTube chat open. So if you guys want to continue the discussions, you can do that there. Our next speaker, who's been patiently waiting, Vasilios Tzanoudakis.
Tzanoudakis, it's not difficult, come on.
Vasily, come on, it's just Vasily.
Giovanni, I love you, man.
He's going to be talking to us about his multi-cloud journey with OpenSIPS 3.x, and he's got a really some cool information. Again, like we want to talk about things. Let's hold some of the questions to the end because he's starting a little late.
Okay.
Vasilios.
Let's. Okay, I think. Okay, so you can hear me and you can see my screen, I think, right?
Both.
Yes, we can.
Okay, guys, it's been a pleasure being with you once again. Of course, we all miss Amsterdam. Of course, I miss you all, guys. I hope to see you in person very soon. We had a talk with Bogdan before starting. We hope to be able to see each other again and enjoy the conference as we always do. So let's get started. Multi-cloud journey, and the journey had started almost about 2 years ago, and I will be talking about cloud adoption and organizations of all sizes are adopting the cloud operating model for their application workloads. As we have seen, this is not happening on companies dealing with SIP and VoIP. And most of us, if you have seen the last statistics reports that most of us, most of the companies dealing with SIP, the cloud adoption is very, very low. Companies, whether to optimize the cost or running and managing their data centers, or to enable development teams to eventually build applications of tomorrow, they are looking for ways to transition, to move to the cloud and change their applications and how the applications are working. So they're all interested in the benefits of the cloud model. But let's see what is happening inside. So multi-cloud. We are not even in the cloud. What is a multi-cloud? And I think this is the reaction of Alex about multi-cloud. Generally, we love our on-premises service. We don't want things to move around. They're just working. We don't want to touch them. So we all love our servers. Okay, the cloud and the cloud adoption is a very complicated thing to do, but I think it's the future. The adoption in our department of SIP, let's say, it's very, very low, but it will happen. So this is just an idea. It's only, let's say, 1/10 of a part of our multi-cloud infrastructure, which has been graphed by our infrastructure as code tool we use. It's called Terraform. So we use that tool to code our infrastructure, and this is just a part of our visualization. And it shows all the resources, all the dependencies, and you can understand how huge this is and how complex is to manage it without the necessary tools. And of
Vasilios,
course,
anyone able actually to read that? I mean, that diagram, I mean, really, if that's just a small part of it, I don't want to see the whole of it.
Just suppose
it's like
In the name of Italy, I refuse to give this spaghetti name.
Indeed, this is the truth, and what I would like to show this, it's not the parts or the names. The part and the names, I can tell you, are resources about networking, databases, variables that are set for each one of these, and which resources depending to what. But I wanted just to show that the multi-cloud and generally the cloud adoption is complex. And what is the main problem? The main problem is cloud adoption for our workloads. As many of you know that the cloud providers didn't build cloud for applications like SIP for us. Most of them, they are built for web applications or ideally any other than SIP. So it's more difficult. One more step for us difficult to let's say create SIP infrastructure in the cloud. And we have to stop thinking about bare metal machines and applications running on those machines on our minds. We need to change how we're thinking about applications and how they're running and where. Because we shouldn't care about where they're running. We should care only about them running ideally and correctly. We should change the design. The design should be totally different for any application running in the cloud. You can just migrate your workloads by creating one instance in AWS or Google Cloud and install all the stuff you were having in your bare metal machine to an EC2 instance, and you can persuade yourself that you migrated to the cloud. But this is not correct. The design is totally different, and it has to be API and event-driven for every piece of your application. So, for example, you have to tune your access list not to use IPs or CIDRs that we all use for our machines when run on our private data centers, and use, for example, OAuth for machine-to-machine authentication. Use tags, use labels, use other things to make applications talk together securely. So let's get an idea of the multi-cloud big picture as we have deployed ourselves, and how I have seen. I believe we should see that. We have Cloudflare, we have Amazon, we have Microsoft Azure, and Google Cloud. These are the three big players of the cloud. We have taken decision to put Cloudflare in front of multi-cloud infrastructure for many reasons. We didn't want to rely. Amazon has a very good, of course, DNS service, Route 53. Google the same, but we wanted to decouple some things. So Cloudflare is a very nice approach regarding multi-cloud deployment. Okay, I hope I persuade you. No. You have to standardize and automate everything. I mean everything about every piece of your infrastructure, every small application, the big application, to make it smaller and more reliable. We use some tools to do that. Packer is one of them. Terraform is another one. They are all tools of the same, let's say, suite of HashiCorp, who they have done a great work the last few years regarding cloud adoption and ways to how to better automate and standardize things, because if it's complicated, you have to standardize it and deploy it multiple times and keep track of it for every piece. So, for example, with Terraform, you can create infrastructure as code. You can code to create a network. You can code to create a sub-network. You can code to create a gateway, a load balancer, and all cloud services that are available right now. And the good thing with that is that you can keep track. You can put the code in GitHub. You can create tags, and you can deploy your infrastructure more and more securely, let's say, and keep track of everything. And of course, regarding the service discovery we were talking before, each application should talk with another application, not with IP address, with DNS names, for example, and proper service discovery should be deployed, and of course doing health checks. We are using Consul in our example here to do the service discovery. So what is a time frame for someone to be multi-cloud or even cloud ready, I would say, because if you are cloud ready, and you have designed well your application, and you have coded the infrastructure well, cloud, multi-cloud is not very, very far between them. But with our experience, what we have seen, it would take, it depends on your team, at least 1 year to learn the tools. It's the life cycle. You need to be familiar with all of them. You need to learn them as any tool available. But we're very positive with the tools. We're using them the last 1.5 years at least, and we think it really worth the time, because right now we can deploy everything in any cloud in let's say in a matter of minutes, and maybe in a matter of let's say days, if we haven't coded that particular cloud. For example, if we create a module for AWS to create an infrastructure, the transition to create the same module for, let's say, another cloud provider, it's much easier. So it's very nice that you almost code once everything. Almost. I say almost, not 100%, but it's almost. Because the tools are different, and the resources are also named differently. But it should take some more time. What we have achieved the last few years with that is we have created custom modules to deal with what we need to install our infrastructure. Sorry. And as we talked before, we created also all the code, and we created tags. We created all of our modules in GitHub repositories to be able to keep track of them and deploy them securely. We have different branches, and of course we are using the CI/CD pipelines using Nomad, another tool of HashiCorp, to deploy Terraform jobs, and also Terraform, let's say, services, which they are running in Docker containers or just applications. The good part with Nomad is that it cannot only orchestrate, it's an orchestrator. Nomad is a workload orchestrator. It cannot only run Docker containers. It can just run binaries. So you can schedule to run binaries and keep track of them. So Google, the last few months, weeks, I don't remember, announced Google Anthos. I don't know if someone is aware of that. Google Anthos is solving somehow the problem that we are dealing with regarding multi-cloud. It's a single control plane to deal with multi-clouds. So as you can understand, this is a problem that is that's existing. The multi-cloud is coming for all of us, and Google, to be able to deal with it, they created their new project.
Vasilios?
Yes.
May I have a question? So I break your presentation, and I have you to speak a little bit more freely, and then you go back to presentation. What is the motivation for going multi-cloud? I mean, I understand perfectly why one cloud, but why multi-cloud? Just for not be locked in, or for having better prices, or why?
I have your questions answered in my last slide.
Okay, that's perfect. I will wait.
So I will keep you awake
That's perfect.
until my last slide. Okay, so let's continue. Giovanni, if you have one design that it's best practice, and I told before, it's more easily you can replicate it. So if you make that design one time, you can replicate it more times. And with the necessary and the ideal tools like Terraform, you can do it with Ansible also, okay? But it's a little bit more complicated. That I think so, in my opinion. Then it's more easily to move to the multi-cloud. So, what is the universal network design? So we created 3 separate networks. One public ones, for example, in the public ones, we're running our OpenSIPS Edge services. So we're running the services that they are dealing with the customers, the registrations. They are running the media proxies with public IPs, and this is the public section of our network. We have private services and persistent services. The difference between them is that persistent and private services are different with not having the private services do not have internet access at all. And the persistent layer has access, but it has access using a NAT gateway. So we decouple the things, and this is the network design, and this is, as you can see, decoupled in zones. These zones are the A to Z zones for each cloud provider in each region. We're using EU Frankfurt for our region in AWS, for example, and the A to Z are 3 different zones that we are running. So let's continue. This is just an example of a module that we have created, that we are passing them variables with different public, private, and internal subnets with our IP address and the different tags, each one with its own /24 network. And we create a bastion host inside of its zone. In the meantime, I would like to say that until I searched deep and deep the cloud and the multi-cloud, I didn't knew what is a bastion host. I didn't knew even what it means. So it's a host that we use to let's say send commands to the network internally.
They call it also jumping host.
Yeah, or a jumping host, yes.
Is the one that you, I mean, in some other kind of architecture, you use it to do the SSL forwarding.
Yeah.
So you take multiple.
This is one of the solutions you can do that. We have also deployed OpenVPN and site-to-site VPN with our routers or with the multi-clouds between them. You can see later. So this is a network design between AWS and Google Cloud, and this is the graph of the code. So we have created resources in 3 different A to Zs for 2 different regions in 2 different data centers, and we create a site-to-site VPN between AWS and Google Cloud, and this is coded using Terraform. And it needs about 2 or 3 minutes to be deployed. And both of the clouds are talking to them using their internal subnets. This is part of the code for this module. We create the names. We put the BGP AES numbers to be able to talk between them and serve the networks. And some small things about Packer. With using Packer, we were able to standardize how we create images for what you will see later to install our infrastructure. For this, we use Packer right now for our ECS instances to create Docker containers. So as a universal tool and the universal way to create our containers and our images. So we define the two different clouds. We run on the commands or different commands for each cloud or for each image. This is defined in the builders, and this is an example of an image that it has installed inside the console and Nomad, and this is a part of the AWS Packer builder. For example, this command that installs the AWS CLI has been run only on the AWS for AWS images. So these 4 images that you see here will only install the AWS CLI. And let's take a look on the pictures. I like pictures more than because it's very easy to understand. So we had Cloudflare, and we have the 2 clouds. We have the side-to-side VPN between them. So all the instances and all the services are talking each other securely. And we do all of it using Terraform, Packer, and Nomad. No bare metal, no machines, and no worries. And of course, OpenSIPS on the edge. This is the architecture about how Nomad runs and how what is happening inside. So here are the console servers that we're using for service discovery. These are the Nomad servers that are responsible to keep quorum of the orchestrator. And here are the clients. The clients means that there are like EC2 or ECS boxes that can run containers or binaries or Java applications or anything. And we are sending the jobs to the Nomad servers, and according to the attributes, we share them among the availability zones or even different regions or even different clouds, which I will show in the next. Here is the big picture. We have our local data center, for example, here in Greece. We are using the same tools. We use Nomad here. We use Nomad in the AWS. So we send a job using our DNS provider, which can, by the way, do health checks regarding the endpoints. So when we're sending the job, we can send a job regarding our corporate data center. We can send the job here. Or for a job here, we can send a job. It doesn't matter where we send the job. This is one that I'm trying to say. So we send the job in the AWS cloud to deploy here some services and here some services. And we do that one time. And this gives you the ability to easily manage multiple things using less code and less effort. So let's see more stuff about how to use cloud services. Okay. Cloud providers, they have some great cloud services and cloud offerings, databases, Lambda functions, serverless, And we need to be careful when to choose which of them to avoid vendor lock-in. Because if you choose a service and you put too much effort or rely your application too much on a cloud service that it's not offered on another cloud provider, or you can't replicate your data between this cloud provider, this gets you into a trouble about going multi-cloud. For example, you can use, if you are a Kubernetes guy, you can use Kubernetes in both clouds, and you can have the same result as using Nomad. If you have a local data center and you want to deal with Kubernetes, okay, I take no responsibility, but you can do it also. In we decided to stay away in Kubernetes for our locally installed servers. We found Nomad much easier to be deployed and much easier to be, let's say, manage it. So be careful which services you choose to use in each cloud provider. So let's go some SIP on the SIP side, just to take some idea of what is happening when a request is coming on the edge of our platform right now. The request is coming, where's the pointer? The request is coming here, and we check for some security. We're doing some security checks, and we're doing some authentication, and we register the user in our Gigabyte cluster. Gigabyte is an open source project. I will talk later. It's we use it as a Cassandra replacement. And then we are moving all the stuff, most of the authorization and billing and authentication part to CG rates. And here, as you can see, we are moving the CDRs to the cloud. This part is a serverless part built to manage our CDRs that the CG rates is generating for us. So we're sending the CDRs to Amazon SQS queue. This is an example on the AWS side. So on the AWS, we use the service, the AWS SQS service. We use a serverless Lambda function written in Go. So it takes the message from CG rates, which is the CDRs. It horizontally scales, and in horizontally scales the writes to the database. We use the scalable database DynamoDB for CDRs. The next steps have to do with more checks regarding the SIP request and the caching layer, and what is happening inside the call to make the necessary decisions about what is going to be done with this call. And this is an example about recordings. So you make a call, you pass the necessary authentications, we have the CDRs, we use asterisk to write our recordings. We use AWS EFS, it's like NFS file system. And you can sync the file store, the Google Cloud file store, which is the same service with AWS EFS. We can use data sync to sync them together, so you have all the data in two different clouds. So this is some ways to deal with the two different things. Some examples. One with the CDRs and one with, for example, with the recordings. So, well, as you can see, we use serverless whenever it's possible. Google has cloud functions for that, and AWS has Lambda functions. So you can use both, but be careful, don't use them too much to avoid vendor lock-in. So be careful. The truth here is that it deals with scalability, horizontal scaling. If you have high peaks, this can be really pain, and this is a way to solve those problems. OpenFast is an open source project for serverless. You should take a look of it if you want to deal with. It has that great feature about non-vendor lock-in, so you can install it everywhere, anywhere. And this is an idea how we manage our CDRs in the AWS side. So the user requests using Cloudflare, and we have OpenSIPS. The request is being received. We have CJH for authorization, authentication, and CDRs, and the CDRs are going through to a broker. SQSQ is a broker service. It's just like having RabbitMQ, but it's serverless. It's fully scalable. And we pushed all the CDRs in the SQSQ, which this service then triggers our Lambda function, which is another application, very small application, a few hundred lines written in Go to receive the messages from the SQS and write them to the DynamoDB database. And then using another function and using the DynamoDB streams, we can take those CDRs and put them into Elasticsearch and be able to store and analyze, create dashboards, and do all that funny stuff. And the whole thing is auto-scaled, serverless, and no server involved, just code, and you're ready for thousands and thousands of requests per second. If you see here, there is a dead letter queue. This queue receives the messages that are not delivered in first place from the SQS queue here. And this queue, we manage it differently internally to be able to see why they didn't move to the next level. But it's a very nice feature that we don't lose any message. Okay, let's go some more OpenSIPs. So we run our OpenSIPs on the edge as a federated user location cluster. And this is our approach. We like that approach. It's horizontal scalability was a priority for us. And we use Yugabyte instead of Cassandra as a replacement for OpenSIP's user location. If you haven't heard, Yugabyte is a very nice open source project, 100% open source project, as a Cassandra replacement or Postgres in scale, with great features for multi-cloud, to avoid network vendor login, and to have a very scalable database. It supports Redis, Postgres, and Cassandra. It supports multi-master or master-slave asynchronous replications. It has automatic sharding, very nice feature. And generally speaking, it's a Google Spanner alternative. And for those of you that have looked at Google Spanner, you know this is a very, very highly priced service by Google. And this project, this 100% open source project, is, I think, a great alternative for free. And if you like replication, cloud, multi-cloud, you should check it. The good thing is that the Gigabyte has a C++ driver for Cassandra, which is based on the DataStax driver. All the tests we have made with OpenSIPS, it's really reliable, no problems at all. So you can use it. So let's talk about CG rates and how we used it. Where we have deployed as a microservice architecture. We use it for rating, billing, CDRs, and Dan Bogos has made a great job regarding features that helped us going to the cloud and also multi-cloud. We are replicating the CDRs. All of our CDRs are replicated in both clouds. This also happens with the user balances. So every time user hangs up the call, the balance deduction and the result is being replicated globally. And we use that replication mechanism to be able to replicate all of our user profiles and that we use internally in OpenSIPS. So our users and what services is being allowed, each one is all inside the CG rates. We use attributes, CG rates module, let's say, to do that. And we are replicating the whole world here. So yes, CG rates made that possible for us. And we have built a custom UI written in Vue.js and some custom Go modules to deal with, let's say, for the vendor CDRs regarding the management, and to manage the CG rates globally. So let's go to what features we have implemented on the edge. So everything that can be done it's, inside OpenSIPS, we have almost made it to work with UDP registrations, TCP, TLS, WebSockets, secure WebSockets, everything work correctly. We are a huge fan of security, and security was a top priority for us. We think that the next few years, more and more customers and implementations will be done using TLS. So TLS and SRTP was a top priority for us. So yes, we did the proper RTP to SRTP bridging. We are using topology hiding. We use topology hiding with back-to-back user agent. The same box has two instances. One instance has the back-to-back user agent functionality, and the first instance has the topology hiding. And so we have win-win situations to hide our topology better. And do also some great stuff in the back-to-back user agent about filtering and security. We created ring groups and different ring strategies. We have different manipulation rules for inbound and outbound. And this has been done not per user, but per DID. So a user can have multiple DIDs, but we can filter them by DID, so a user can have multiple rules for each of their DIDs. Of course, we cache everything. We wanted high performance on each of our OpenSIPS instances running in the edge. on the edge. So we cache everything. Everything, I mean everything. And if something is changed, we post that change using the API or of OpenSIPS API to purge or cache a variable, let's say the password of the user. So we have tested and working great SIP trunking. We have tested with many providers, many vendors right now, Panasonic PBXs, 3CX, with UDP, TCP, and TLS endpoints. These are all implemented in 3.1, the latest 3.1, and we are very, very satisfied about the performance and the interoperability test we have done so far. So some more features. Inbound and outbound call limitations per direction or totally. We are doing some filtering and some security stuff in our back-to-back instance. Before this is done, before the call reaches our application server or our SBCs. Of course, we use the statistics module, the benchmark module, which helped us a lot doing debugging of each function that we have implemented to see, using the benchmark module, we built a better caching mechanism because we were able to see all the latencies that were created by each function and be able to make them better. So, of course, we are able to configure the invite timeouts per SIP rank. And we have our forwarding service with different string ring groups and strategies of the regarding its user and per DID. And of course, very nice features from user location regarding the ping latency and the registration lookup. We have testing them and they are working great. And of course, the MS Teams integration, which it's very, very important for us. Right now, we think the MS Teams are #1 regarding this web conference and unified, let's say, communication. It's been used by many companies. So yes, we have implemented the integration with MS Teams also. So let's see an example about our user profile in CG rates. Here you can see a line which has the user configuration about let's say a trunk. True, false. It has to do if this rule is enabled or no. It make the user more. It make us more easily to manage it. Do not delete it, but stay there. We have the DID. We have the user IP, the target port. If it's a UDP, TCP, or TLS endpoint. Maybe some other stuff that we needed to register, let's say, or to send the request using a specific from domain. The queue value that we define the priority, and some other. Okay, let's do that. Some other functions here about the timeouts, and this is per DID, as you can see. So we receive all these variables inside our OpenSIPS script, and this is how we use CG rates for our user profile. And remember that all these configurations are replicated globally, and they are cast locally in each A to Z zone. So finally, Giovanni, why multi-cloud? Okay, we wanted to build our services to have, our target is 5 nines. Okay, so the motivation for this is 5 nines and more. So this is the main reasons, and we wanted to have better redundancy in case of region or DC failure. One year ago, if we were talking and we're talking about going, let's say, stay in our houses, that there would be a pandemic, nobody could believe me. That's right. That's for sure. But maybe this is another way to be ready for the next pandemic. We wanted the best for our business also. So 22301, it's a very important ISO for us. It has to do with business continuity. I have to say here that all of our customers are enterprises and are business customers. We don't have retail customers at all. So yes, this is the most important part for us. Avoid vendor lock-in. We didn't want to be locked in one cloud provider. There are customers or ISO authorities, but they can ask you and say, okay, AWS is great, it's the best cloud of the world, Google the same, Azure the same. And what if you have all your infrastructure in the AWS cloud and something happens and AWS is down? Okay, you can't, it can't go down, you say, but if it's down, what will you do? So we needed an answer to that. So the only answer to that is multi-cloud. And of course, we wanted the best possible experience for our SIP service and our APIs. So of course, and the last part was the most important for us. So we wanted to reduce our heart attack risk for me and my team. So remember, we need to sleep well. So I think this was the last reason, Giovanni, to ask your question about multi-cloud or cloud in general. We truly believe that this is the answer to many of our problems. But I have to say it's not an easy task. It's almost 10 years for me to be able to finalize all or some of the stuff that you have seen and make them work together. Okay, we're a small team here, but if you even in a big teams, if you are going to cloud, if you are doing the transition to the cloud, it's going to take a long. It's not a short journey. It's a long journey. And these are only some small parts of it. So that's it. I hope you enjoyed. Sure. Okay, you can see this.
Yes, we can.
Okay, it's 9. Okay, we have very little time or no. This is our database cluster. This is our user location, OpenSIPS user location table. Yeah, it's working. It's replicated 3 times inside the AWS right now, and yes, it's working. So let's take a look to to one of our clusters running in our development right now. Here are our services. Just an example about two RTP engines and one MongoDB, for example, running in 3 different zones, in 3 different boxes. Let's say they're running Docker containers. And here are the databases running in EC2 instances for better performance. And these are the OpenSIPS server that running on the edge in 3 different zones, for example. And one more thing, I think I have some time to do that. I want to share another window. Okay. You are seeing yes? Okay.
Maybe bigger font. Just one plus.
Okay, fine. But let me tell you.
If you can't.
Yes. Okay. I think I can. You see something? Okay. This is a Terraform module. You see, right?
It's okay. Yeah.
Okay. This is a Terraform module that it's ready to be deployed in when an auto-scaling event happens. So we have too many calls. We have and our edge servers are struggling, and it fires an event for 3 instances to be done. Let's say 4, 5, 6, or 7. So this is so. This is changing. This is just a module, just to show what it can be done for the automation part. This module creates the extra tables for the cluster module inside the database regarding the instances that are running OpenSIPS, the new ones. So we create the instances. We run the Terraform module, and it creates the MySQL insert commands, and it's ready. It's run. And here. You see the screen, right? You see the databases here?
It's visible. I guess people can go full screen if they want to see them, and they can replay the video.
Okay.
Yeah.
So if you use, let's say, go into the zone 3, the database zone 3, and you select from the cluster, it dynamically created the cluster and the IDs. We have ID cluster 1 and different nodes. And it took all the necessary information about the local IPs and the public IPs for its node. So this is just an example of what is going to happen in an auto-scale situation, and how we use Terraform to deploy our auto-scaled OpenSIPS instances.
There's a question about this. How do you test those events? Do you actually exercise that everything works, or what is the methodology and strategy?
it's the events can easily be triggered. For example, in AWS using the CloudWatch. But if you are referring to CPU loads or other, let's say, variables like code, for example, yes, they can be done, both of them, or anything you like. We haven't reached that part yet, but we have the whole idea programmed. So this part that would be the last part of our implementation. So that's it, guys. I hope you enjoyed the journey. I hope it wasn't too much information. I'd like to show more screens than letters. And I don't know if I have persuaded Alex to go multi-cloud yet. No.
Well, you're persuasive. You're very persuasive.
Okay, that's very good, because I know you love your own premises.
That is correct too. Actually, we just finished buying a /22 for a new Anycast network. I don't think we're gonna get into the multi-cloud.
You cannot beat the latency. Like speed of light is still limit. So having on-premises has some advantages that you cannot get with the cloud. But
yes,
they are. I mean, look, again, I have no issues with the cloud signaling wise. It's when it really comes to the media services that I feel that you're at a serious disadvantage unless you've got some really expensive setup, like, you know, you're a Twilio or you're an Uber or something like this. Other than that, I mean, it's still amazing to be able to create, you know, the type of network that is low latency, that can find the quickest links between you and your endpoints. Having those types of services and having a huge edge like Amazon, Azure, or Google can give you in regard to that, I see that being extremely beneficial though.
one of the best parts of that had to do with DOS protection, for example. But I have to say, Alex, that we keep our media local, and our plans here are to have dedicated fiber optics with AWS, for example, for our interconnect. So
for the interconnect, yep.
That is to answer your question and your fears, which I really understand.
Do we have any other questions out here? Okay, I do want to make a quick plug for Sippy Labs and Maxim Sobolov. He has a Patreon link out there that basically all the proceeds go to really cool, like, open source projects, like the controllers that he does. And I think it was a mention of a robot. Is that right, Maxim? Did you say a robot?
It's more for practical purposes. We've been little bit struggling over real OpenSIPS summit. This one is easy because everybody is kind of strapped to the chairs, so nobody moves around. But if you look at some of our streams in the past several years, some of the presenters, particularly Giovanni, is very well known about this for this.
Not staying in one place.
Tend to run around a lot. So this guy could basically track. You put a camera on top and put it on the mount, and that basically.
So you want to track Giovanni's activity for?
Yes, exactly. Yeah. Make sure he does not do anything wrong. But yeah, we tested it in JanusCon in September, and it worked reasonably well. So the hope was to bring it to OpenSIPS Summit as well. I was also starting building a little like encoding box. This is Xeon D, pretty good edge computer motherboard, so you can put like video card. And I actually bought a case for it, but it got stuck in US, which is 20 kilometers, but I cannot go there. So yeah, basically
For your own protection, trust me.
shit. Anyway, don't get me started on this. So anyway, if you guys can help us like few dollars and anything, would be really appreciated. Over the time, as I said, we've been running this for 2 years, and I know some of the people in, at least in the moderator team, I think Shlomi and Nizan, and also our friend Flavio helped us over the years as well. So yeah, thank you.
We were there too, then COVID hit us.
Yeah.
So guys, there's a question on the Slack for Vasilios. Just a second. So do you recommend use SD1 for VoIP as delivery service to endpoints?
Okay, I fully understand the concept here, and this had to do with the talk with Alex before. If this SD has to do with software defined, if someone doesn't know, understand that. If you are able to protect that one, then you shouldn't have any problem. I would recommend to not put things that will increase latency in any ways. So, for example, on our Edge, OpenSIPS Edge instances, we run them in Docker mode in network as a host. So, as you can understand, we'll try to eliminate any latency that will be for our RTP engines, for example, for our media proxies. So as soon as you keep the latencies low, there is no problem with any software-defined solution or any solution. So the latency low and the protection of the line also. So I don't see any problem with that.
Okay. Anyone else? Here's Anshuman is asking, are you using Direct Connect?
Yes. Yes, we are using Amazon Direct Connect for the interconnection. So that means we have direct connections with our AWS VPC, and we are connecting the on-premises data center with AWS.
Okay. Any other questions out there?
Vasilios, it's Flavio. Have you evaluated the open source orchestration platforms such as OpenMano or the, let's say, software-defined telecom stuff from the Linux Foundation?
Which one?
It's network function virtualization, and the name of the project is OpenNFV and OpenMano, OpenMIO.
Could you please write it, because I can't hear you very well.
Open chat.
Actually, while we're getting that, Jonathan Abrams asked, has the recent Cloudflare outages caused any issues for you?
No, yes, I'm aware of that, but we didn't have any problems regarding the DNS part, or it didn't affect us. I know that where we saw some outages the last few, let's say, months, but because I'm following them, regarding the DNS part, they are pretty stable, or at least they didn't. We didn't have any problems with the DNS part. If we are talking about the caching, the web caching part, yes, we saw some, but we don't use that for caching. We only use as a DNS provider. So they are pretty stable for that.
Okay. We have Flavio's question yet?
Yes. I am aware of the project. The truth is that I didn't have the chance to look deeper and further, but I will. I promise, and maybe the next presentation will also have this.
Thank you.
Flavio, yes, I have seen what is happening here, and this is yeah, this is the next generation stuff.
Just
They're building
question.
IMS to terminate calls for 5G, completely open source and cloud native. So it's more or less in the same direction than what you're doing.
Yes, I definitely take a look of it more seriously, and I like to learn things, to have the idea from the inside, so I have better view, and that is what I learned the last few years, reading and testing and deploying, and this presentation was a very nice journey to be able to choose the better part that fit our business and our needs. So yes, I will definitely look at it.
Great.
Thank you.
Great. I think that we have to cut any other questions off at this point. We're running about 15 minutes late, and we definitely don't want to end this day without our raffle.
Yes, we are.
So, Liviu, how is the status of the Live AI?
Yes,
I think we have a new version today.
Look at that, ladies and gentlemen. Our incessant need for perfection has brought another version of the Live AI. Actually, yesterday's version was quite nice. It seemed fair. Seemed like people had a chance. You want to get your screen shared up? And do we have Celeste in here?
She was in the list. Celeste? Celeste?
She joined.
But she's
here.
muted.
Do not mute yourself. Unmute. Slow your roll there, Live AI. I was hoping to get Celeste in here from QXIP to give us a little bit more information about what these 1 hour sessions involve with them. I think we've got a pretty good idea that there's a lot of dancing and lack of clothing in the OpenSIPS ones, but we don't have an extreme amount of information about the QXIP ones. I'm going to give her about another minute or so here while we do the drawing for this amazing, maybe 75 of a kind, OpenSIPS 2020 Summit distributed t-shirts.
I think Giovanni is the best.
Giovanni, like you definitely have like a future in modeling, my man. So without much ado here, let's get the picker warmed up.
All right.
Who's getting that t-shirt?
Anytime now. John. Who's John Osterl? I hope I didn't ruin it. Osterl.
Okay, let's see if he's here.
John, are you here?
Type something on the channel. On the
Write something, John. Don't make us give this amazing prize to somebody else.
There is
John,
he
John.
seems active.
John, you're about to lose your t-shirt.
What's the deadline?
Ay.
Just 30 seconds.
I think we need an executive decision on this.
Not again.
Ay, John.
So let's make it to maximum 1 minute.
Maximum 1 minute. So 21. Or
Okay.
sorry, maybe it's not 21 for everyone. I just realized. Yeah.
Well, so
Well, it's faster in Romania, obviously. But...
John!
John?
John, where are you,
John.
John?
Well, he went for the grocery.
30 seconds.
This is one P break he's definitely gonna regret.
Yeah. It's those moments.
Well,
All right. Brett makes a good point. We have to take into account the YouTube delay.
why? He should be on the
No,
on
he's
the
in
Slack, which is
No,
more or less
because
real
He's
time.
on Slack.
It's real time.
No, no mercy.
No,
Look,
Okay.
there's no competition for this, guys. Take it easy. All right, take it easy. There's another one being given away tomorrow. Take it easy.
The time is up. So
Oh,
it's
all right. Part of that
Sorry-
new
sorry,
that
Dan.
new update to the Live AI was the automatic timer. Seems to have kicked in. So
right. 3, 2, 1.
and
Nick.
Nick.
Yay!
whoa!
Our friend Nick.
yeah,
Nick, are you around?
Oh,
Congratulations.
he is. Oh, he's
He
there.
is. Yeah.
Great. Congratulations.
Nice, nice.
Congratulations, guys.
So
That's a
So,
pleasant surprise.
While this has been happening, I think that just might have been enough. Is Celeste around? She back?
Mm,
I think she dropped out, but she was.
Here she is.
Apologies, I have a little problem with connection.
Hey,
That seems to be
ciao,
going around
Celeste.
today. Don't worry about it. Celeste!
Hi, Celeste.
Good evening, good morning, everybody.
You know, you showed up just at the right time. The Live AI is
Awesome.
getting some maintenance. It's in the pit stop right now. It's done a few laps.
mm,
And while that's happening, can you tell us a little bit about what our lucky winner should expect with their 1 hour with the QXIP team?
Oh, well, the best of the best is always from our team. Now, we are planning, of course, to do something that is going to be tailored. So whoever is going to be the lucky winner, we will contact them personally and see what is the challenge that they are trying to face with Homer and see how we can help them.
Great, great. Well, you heard it, guys. This is your chance. 1 hour just with the team.
shall I send
Live
it?
AI.
Because
Are we ready?
yeah, we are getting late. So go on.
Let's see.
And the winner is
Plamen
Plamen Petkov.
Let's
He's
see.
Carmen, are you here? Are
They
you
are.
here?
Say
Type
something.
something, man.
Type something.
Plamen. Make yourself seen.
Wake up.
Give us a proof.
Carmen!
Okay. 1 minute starting now.
Your time is running, guys.
And you're losing, you know, the ideal design clinic with the QXIP team.
What a shame.
Yeah, shame on him.
Plamen, Plamen.
Now that is going to be a really expensive P break for that guy.
Seconds.
I do not want to be that man's bladder.
Plamen, Plamen.
Okay. Leave you.
Live
How are
AI.
you on the time?
15 seconds.
Ooh.
Ay, 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 ay.
That'll be
No.
painful.
Yeah, not looking good.
Yeah.
5 seconds. And
Well.
3, 2, 1.
Just
Okay.
do it again.
Wow.
Okay. All right. Attempt number 2. Yay!
Yeah, that's exactly what I wanted.
Really?
Guys,
Really? Again?
Congratulations, Razvan.
There might
No
be a bug.
way. No more husband.
We might have a regression.
Razvan, you shouldn't lose that.
There may be a regression in the Live AI, guys. We will fix it until tomorrow.
It's a 24/7 service.
Guys, this is unbelievable. Come on.
Sorry, guys. Sorry, guys.
I think that he put the other Live AI in before.
Nice, nice. Okay, try again. Thank you, Livio. Thank you, Livio. Okay, let me take. It's what we have arranged, Livio.
The money's in the mail.
Okay,
Wow.
I like it.
All right,
Kevin.
Kevin.
Are you here, Kevin?
Do we have Kevin around here? Kevin, come on, come on, come on, come on, Kevin.
Okay, 1
Really?
minute. Oh, he's here.
Congratulations!
Congratulations, Kevin.
Awesome.
Awesome. Awesome. Well,
that's fantastic.
I was starting to think that we couldn't give this stuff away. I was proven wrong.
And now,
Wow.
you must rush.
It needs
Think of
to
some
be
question.
deserved.
We definitely need the stable release for Live AI tomorrow, right? We have the
Seriously, it's the last one, man.
yeah the 5.0 5.0 for tomorrow. Yeah.
Oh. Well,
Tight.
that was an absolutely amazing day. Day 4 now is in the books. We have one left. Thank you so much to all of our presenters today.
Was a great
Giovanni,
job. Great.
Vasilios, Shlomi, and Vlad that attended today. You had some great questions. You had some great conversations that we kept going. The only reason that we're late is because everybody was really interested and wanted to know more about what we had. So I hope you bring the same enthusiasm with you tomorrow. We'll be starting at the same time. And we have some amazing super prizes in tomorrow's raffle. This is the one that you definitely don't want to miss. We have, I believe, you know what? I'm going to keep it a secret. Bogdan is, with his eyes, he's shushing me. There are some amazing prizes tomorrow. They're the biggest ones we've had yet. We look forward to seeing all of you again. Thank you again. Give yourselves and everyone a round of applause. Day 4 is in the books.
Good job, everyone.
Thank you, Alex. You're my Greek goddess.
And
Thank
let's
you.
not forget the great
I'm
audience.
sorry you had to hear that, Vasilios. I'm sorry you had to hear that.
MC Alex.
Congrats.
Thank you, Maxim.
Bogdan, do you have any closing statements?
I'm just, I'm just a bit sad that tomorrow will be the last day, and it's like at this point we start, besides the version of the for the raffle, everything went smoothly. It's like a great engine. Producing this event, we have to to put the proper version on the Live AI, but yeah, that will be fixed by tomorrow. So tomorrow will be the best possible day, I would say.
That's amazing. I think that the luck is in the audience tomorrow for sure.
Yep.
Well, everyone, again, thank you so much for attending today. We look forward to seeing you again. Thank you to all our moderators, presenters, Maxim Sobolov, for making such an amazing presentation to our YouTube viewers and keeping us moving all day. Thanks, everyone. Have a great day.
Have a
Thank you
great
very
day.
much. Good night.
See you
Good morning.
tomorrow.
Good
Bye-bye.
afternoon.
Bye.
Tomorrow.